So, hello everybody, and welcome to this workshop on screenshot testing, libraries for Android. My name is Sergio Sastre. I've been doing Android development for over 9 years. Regarding screenshot testing, I've written a lot of blog posts, all of them featured in Android Weekly. I've also done a lot of open source contributions, so I'm pretty good at this topic. I really know what I'm doing, so you're going to be in good hands. So the tools for the workshop, well, it's going to be a live coding session, yeah? So everything that I'm going to do, you will find it in the first repo that you see there up. So I mean, you can download it and code along with me, or you can just take a look at the things I'm doing and later try it on your own, modify things when you have time. This repo is using extensively this library that is called Android UI Testing Utils. I'm also the author of this library. Whenever you see on my slides this ninja icon, I'm referring to this library. And also, I'm going to use Android Studio Electric IL because of Android Gradle plugin issues. One of the libraries is not supported by Android Gradle plugin 8, and therefore the newest version supported is Android Studio Electric IL. But anyway, for the other libraries, you could use any Android Studio version. And also, I'm going to use an emulator, AP30, Pixel 3a. This doesn't really matter, just in case that you want to check the results. Well, so let's go with the workshop agenda. First of all, I'm going to talk a little bit about what is screenshot testing and how it works, and the existing libraries. By the way, how many of you have absolutely no experience with the screenshot testing? Okay, then it's good. Yeah, I will go through it. Then we'll write screenshot tests that can run on emulators or devices. Then JVM screenshot tests with Roborazzi and Paparazzi. Then I'll show you how you can also write the screenshot tests under different configurations, so locales, custom themes, font sizes, and so on. And then I will give you my opinion, my final thoughts on these two things, on-device and JVM screenshot test. So let's start. So what is screenshot testing? This is a special type of UI test in which you inflate a view or a composable, you take a screenshot of it, and then you compare it to another one that is considered your source of truth. And this comparison happens pixel by pixel. So how actually screenshot testing works? There are mainly two tasks. This is important. There is the record task and the verify task. In the record task, we basically take a snapshot of the view that we have inflated or composable, and this usually is run locally by the developers. Then we have the verify task that does exactly the same, so it records a screenshot. It compares then this screenshot to another one that is considered our source of truth, and that we have previously uploaded to the CI. And this usually runs on the CI. So, but let's see what's the process, how these two tasks are connected. So, first of all, you write code with some visual changes, and you also write the screenshot test for it. So then you have to execute the record task, and this will generate a screenshot file. Then what we have to do is create a pull request with the code changes and this screenshot file that is generated. Then our peers will review it, both the code as well as the screenshot file. Also, the designers can be involved to check that the visual changes are actually what we wanted. And when it's eventually approved, then we will merge it. And this will be uploaded to our CI, so this will be our source of truth from now on. So we are always going to compare to this screenshot file. Then another new pull request comes in. This one, let's say that has no visual changes in the code that we have modified, that we have pushed. So the verify task is triggered in our CI. So since we have made no visual changes, it generates the same file. Then the comparison happens, and since both look the same, then we get a green build. But then another pull request comes with some code changes, visual changes, and the verify task is again triggered. Then it generates another file that looks different, and when the comparison happens, this actually fails. So there are two reasons why this might fail, depending on whether this change was intentional or not. If it was intentional, it means that we forgot to record new screenshot. And that's actually good because it's forcing you to prove that the changes to the existing layout look good, and also to prove it to the designer, maybe, if he's involved. And if not, it means there was something broken. We introduce a bug in our code change. So regarding the verify task, it's actually important that it is done differently regarding the library. So I'm gonna let's explore this for Shopify Unshot, that is on the left, and for drop shots. So let's start with the first one. So we have our screenshots on the CI, and then we execute the screenshot test. So what is going to happen is that we are going to generate for the first screenshot test one screenshot file. For the next one, another screenshot file. And once we are done with all the screenshot tests, we pull them out of the device, then we compare them, and if they are the same, we get a green build. So basically, these libraries need a Gradle task that waits for the test to finish, pull the screenshots, and then verify in the local machine. So you need a Gradle task that does all that. Well, with dropshots, it's a little bit different. So you also have the screenshot files. And the first thing that it does is it pushes those screenshot files into the device. And then for every single test, it's going to generate a screenshot file. And it compares the screenshot files on the device. Then if they are the same, it's green. Then it comes the next one. Again, generates another screenshot file. If they are the same, after the comparison, then green. And so on and so on till you execute all your screenshots. And this is actually important. Why? Because this is how you would execute standard UI tests from Android Studio. Yeah, you click on this green button, this rectangle, not rectangle, triangle, and then test verification, test verification. So this also means that dropshots does not need its own task. It can reuse the connected Android test task to execute tests. That means you can run screenshot tests with dropshots from Android Studio directly. So after that, one more thing that is important regarding verify is the comparison algorithm. Every single library uses a different algorithm. Here it's actually important that Roborazzi, that is the second one. The first one is Paparazzi, then Roborazzi, Dropshot, and Shot. We're going to see all of them. So Roborazzi and Dropshots use Defer, which is an open source library from Dropbox. And what this does is it compares two bitmaps, but does some color matching and anti-aliasing corrections before the comparison. This is important because, this is especially important for device screenshot testing because hardware acceleration on the emulator. So it means the screenshots are rendered using the hardware of the local host machine. So if you are recording the screenshot test on a MacBook with a Intel chip, and then you verify on a MacBook with Apple chip, maybe the colors are not the same, and this library, Defer, helps to mitigate this issue. Well, so which are the screenshot testing libraries that exist? There are several. The most popular are these. So we have Paparazzi, that is the most popular. The first one that allows you to run a screenshot test without an emulator or device. Then a screenshot test for Android from Facebook, was the pioneer, the first one of all of them. Shot, which is built on top of Facebook, and also generates some nice HTML reports with some diff images for failing test. Then we have Android Testify from Shopify. This was the first one that allowed you to run a screenshot test under different configurations. Then Roborazzi, that is an alternative to Paparazzi, also running without emulator or device, but using Robolectric native graphics. Dropshots that can execute tests from Android Studio, and also has this mitigating algorithm, comparison algorithm that mitigates flakiness. And Snappy, that is the least popular, but it has the peculiarity that you can run a screenshot test on the device as well as on the JVM with it. So from all these libraries, these are those that can execute the screenshot test on a device. And these are those that can execute the screenshot test on the JVM. There are two groups, yeah? Those that use layout lib, that is it's what Android Studio uses to preview views or composables, and Robolectric, that uses Robolectric native graphics, So this is important because there are remarkable differences between both. And I will also mention them during this workshop. So it's also important because maybe you want to build your own solution based on Robolectric, and you will know what is possible, what is not. And also because Google is going to release its own solution, apart from Robolectric, that is based on layout lib. So you are also going to know what are the limitations. So these are actually the libraries that I'm going to cover in this workshop. I cannot cover all of them, sorry. So it's coding time. So let's go. Now for you to see this, I believe I have to click here. Yes, very good. So first of all, I'm going to present you the application that we are going to screenshot test. And it's this repo, yeah, that I mentioned. So yeah, Android screenshot testing playground, I think it's called. I created it, but I don't remember very well. So yeah, there are mainly three things here, three UI parts, so to speak. So we have the dialog, that is just a custom dialog with a couple of buttons. I'm not going to cover this in this workshop. And then we have views and composables. So yeah, for the views, yeah, for the views, it's just purely a recycle view, so with some view holders. It's a language learning app that I created with some nice animations. This is the training row. This is what we are going to screenshot test, and there's then some other view holders, so you can delete the stuff here. I want to show you what happens when you delete all of them. Then you come to a very nice holiday mood, so you have no words to learn. So this we are also going to screenshot test. And then we have the one for the composables. This not work. It's a lazy column. And you have an app bar here at the top, and then a list of coffees, because developers love coffee. And when you click on one of them, it shows a snack bar. Good. In the repo, you're going to find here dialogues, lazy column, and recycle view screen. And under every one, you will find that is split into library names. Yeah. So the screenshot tests are written exactly there for each library. It's everything configured by default. And let's start then with, I will say, on-device screenshot test with shot. And then we'll do it for drop shots. And I'm going to do for activity, then for this training view holder, and then for composable. So I'm going to uninstall this, because otherwise I will get an error like, but it's not so important, you just have to uninstall the app. So let's go with shot. Is the size, big enough? I think so. So shot, Java, utils. I'm probably in the wrong branch. No, I'm in the right one. So then I don't understand why this is not. Well, I'm missing something. Sorry. Dialogues, of course. I was wrong. So here, recycle view screen, shot. Then we go to Java. This is not in the repo. I created this workshop exactly for this workshop. But all the other examples are here. Activity, bitmap, fragment, recycle view, everything. So we are going to start here. And for testing an activity, we are going to use an activity scenario. This activity exactly. So the activity scenario rule and the name of this activity that you have seen with these nice animations, the language learning app, is language training activity. So for short, it's important, it's documented actually to support activity scenarios. We have to use one method that is called wait for activity. That is this one here. Yeah. And after that, we need to take a screenshot. For that, shot requires that our test inherit from this interface that is called a screenshot test, as you see here, so Karumi. So we click here. Yeah, and then thanks to this, let's explore it a little bit. We have the compare screenshot method. Yeah, for activity, we can also screenshot a fragment. We can screenshot a dialogue. The same for view holders that we are going to use, views and composables and so on. So I basically have to write, yeah, compare a screenshot. Here we have an activity, and then we give it a name. And it's going to be activity, very original, yeah, I know. And now to execute the screenshot test, since I only want to execute this screenshot test and not all of them that are in this repo, we can use actually one filter. That is this one that you see here with package. So the package is going to be workshop. And here I have the one that I want to record. So I copy this, go to the terminal, and execute this. It's going to take maybe a while at the beginning, the first screenshot test. But after that, it's going to be much faster because I've enabled configuration cache. And all these plugins from all the libraries support it. So I don't think it's going to take very, very long. Don't worry. Stay with me, please. Yeah, execute it. Something happens. Yeah. And then at the end, with shot, we are going to see this here, yeah? It's an HTML. So I open Google Chrome, and I paste it. And don't worry, because it's not going to be displayed. It's going to say, hey, not found. Why? Because this is wrong. The path that they give is wrong. You have to remove this index HTML, go here, and then we will see a very nice report. Yeah, this is the report from shot. And then we take a look at the screenshot that is generated, and we see that, yeah, it looks fine, but where are the shadows of this car view, yeah? Well, for this, there is something important that I'm going to explain now. So we are basically, from a view, creating a bitmap, yeah, for the screenshot. And there are two ways to do this. One is using canvas, which does not render elevation, like shadows, but it can render views that go beyond the screen, so like scrollables and so on, if you want. Then we have pixel copy, which renders elevation, but it's supported only from Android or on, so API level 26. And the other problem is that if the screen you want to, the view you want to screenshot goes beyond the limits of the screen, it will resize it and the image will look distorted. Yeah, that's one of the limitations. So, okay, I understand that, yeah? So we need a bitmap that is taken with pixel copy. So because shot uses canvas by default. So how can we do that? Well, so first of all, shot supports a bitmap as a parameter. So now we just need to a bitmap out of this view created using pixel copy. So for this, there is this library that I mentioned before, Android UI testing utils, that has a method for that. So we just basically say activity, and then draw to bitmap with elevation. And then we execute the test again. That will be faster now, I hope. And yeah, we'll see if it displays the shadows or not. So now I don't copy the index, and I'm gonna use it here. So I click, I do like this, record. Ta-chan, it has shadows. Yeah, we made it. So you see, it's different. Exactly, so that's the trick. You can use bitmap for that. And yeah, so now let's do the same, but we want to screenshot. Let me see what I told you, this part, yeah? Exactly this part. So the training view holder. So well, what we could do is, yeah, exactly as we have this test, we can use find view by ID and so on. The problem is, okay, in this activity it's not a problem, but imagine that we are fetching data asynchronously. So it means that we would have actually to wait till the data is fetched for taking a screenshot of it. But actually what we want is inflate a layout, populate it with data, and take a screenshot out of it. Why should you wait for information to be fetched? Yeah, for that, what we could do is use an activity scenario that launches an empty activity, and then inflate the layout into this activity, and then populate it with the data we want. And for that, there is also, from Android UI testing util, something that is called activity scenario configurator for view rule. There is the same for composable that does this. And this actually provides, I'm going to delete this, provides such a method. So, moment, lay, exactly. So provide this inflate and wait for idle method that will do exactly that. So the training row, because I told you it's called training, and then we want something also from Android UI testing utils. Training view holder, I think it's this. I'm going to explain this in a while. Don't worry if it looks very weird. So you see this wait for message view holder, also from Android UI testing utils. Everything that happens here inside runs on the UI thread. Yeah, so basically, we are creating the view holder with the layout that we have inflated, and then we populate it with the data we want. Then this wait for message view holder will force the layout to measure again, so we know the measure height, and then it will wait for the UI thread to be idle. So after that, here, we just have to screenshot test our view. So we use, again, compare. Oops, not composable, not yet. It comes. Compare screenshot. And then it also has for a view holder that is called holder. And then here we say view holder. Yeah. Then here name, that is going to be training view holder. And it still does not compile because it also needs the height. This method from short needs the height, but it's also not a problem because we have, oops, not item view, and we have, as I said, measure height here because it was remeasured. And then we just execute this again. Yeah, as you see, yeah, this is a little bit more code than before, but still manageable. Yeah. So let's see what we got. Record, index. Yeah, very good. So now for composable, yeah, this is in another in another module. So not in recycle views, but in lazy column. So again, shot, I do the same, screenshot test here. Here is gonna be screenshot test composable. So here, and again, I'm gonna use from Android testing utils, the analog, but for compose. So this is activity scenario configurator for composable. Yeah, exactly. And then here, yeah, so we are gonna populate this. I mean, set content. And then I have here, yeah, exactly this coffee drink list item, so only one of the items of the lazy column. And it's gonna be a default one that is an Americano. It's just coffee drink, but it's an Americano. And then what we have to do is to take a screenshot of it. Of course, I have again here to add the interface, extend from the interface from shot, and compare screenshot. And as we have seen, there is something that is called rule, that is a compose test rule. So I have good news for you, and is that this activity scenario rule from Android testing utils has a lot of things. It has a compose rule, activity scenario, and a compose view as well. So we can use the compose rule. We give it a name again. This is going to be coffee, because developers love coffee. And we execute it. So this one, record. Yeah, as you see, it's very simple. I mean, give me a second. Yeah, writing a screenshot test is easy. I mean, you don't need too much code to write, yeah, so. Yeah, Americano. Let's see. Again here, this is wrong. Yeah, I think I will make a pull request to fix that because it's a little bit annoying. Ah, okay, yeah. Record. Yes, here we have. By default, when we use the compose rule, shot will draw shadows for composables by default. However, there is a problem with this method, and this is, the problem is that it supports only from Android Oreo on. However, if you want to take also a screenshot test for composables for lower API levels, you can always use bitmap, as we have seen, and then we can use, again, activity scenario rule, compose view, and then draw to bitmap, bitmap to elevation, and so on, and it will work. So it's also not a big issue. Well, that is for shot. So we have finished. Then let me go, let me go for drop shots. So we are going to do the same. No, actually, no. We are going to do it only for the composable, because for the others, it's almost the same for the activity and training view holder. So if I show you one, I think it's more than enough. So let's go to drop shots. I'm going to close all the classes here, because otherwise it will. Oh, so many. Oops. So, lazy column, drop shots, workshop, screenshot test. Here, so we are gonna do exactly the same, for this coffee list item. So again, a screenshot test for composable. We use this activity scenario configurator for composable. And then here, so we have the activity scenario rule, set content, and then again, this coffee drinks list item. So now we have to take the screenshot out of it. Wait, this is gonna be coffee drinks. Yeah. For that, dropshots does not use an interface, it uses a test rule. So like this, drop shots, easy peasy. So now we here use drop shots, and then we use the method assert snapshot. So why did I want actually to take to show you how to take a screenshot for composables is because with this assert snapshot, you can only take screenshots of activities, bitmaps, and views. As we have seen, it's not a problem because we can take again from a bitmap. No, let's take it of a view. Well, it doesn't matter. Bitmap or view. Let's go for bitmap because I can draw elevation. What I cannot do with the view because this also uses canvas under the hood. So yeah, boom, boom, boom. Yeah, activity scenario rule, then compose view, and then draw to bitmap with elevation. And let's give it a name also. That is gonna be coffee again. Very good. So as I told you, and yeah, you can take a screenshot test with Android Studio. I mean, directly in Android Studio without executing this command, right? So in order to do that, yeah, we have to consider there are two tasks. Yeah, there is the verify and the record task. How can we distinguish that? Well, we can define a gradle property. No, not define, it's already defined by drop shots. But we can use it. Oh, it's false, gradle properties here. That is called drop shots record. Whenever this is here in our gradle properties file, it will record. When I click on the button, whenever I have to synchronize, yeah. Whenever this is not there, then it will verify, as we will see now. I'm going to change to project because I want you to see the screenshot that is going to be generated, hopefully. So lazy column, drop shots, SRC. It's going to be generated here under the screenshots. So now, exactly, if I click here, it will generate a screenshot with the name coffee. Yeah, it's the first time that I'm executing a screenshot test with drop shots, so again, it can take still a while. Gradle build running. Yeah, and here, coffee was generated. Very good. Yeah. So, yeah, that's what I wanted to show you. What happens if now we change this and we say latte? So it's going to show latte instead of Americano. And here, gradle properties, I say I want to verify. Yeah, so I want it to fail. We synchronize again. Yoo-hoo. Then I click on it, and the test should fail. If not, I don't know what's going on. You can also execute the screenshot test from the command line, yeah, of course. Yes, and it's saying, oh, 3 point something pixels differ. Yeah. Good. So that's basically it. You can execute, record, and verify from Android Studio directly just by changing this gradle property. Something important is that with drop shots, you can define a tolerance. So for pixels, so instead of saying, yeah, 3%, I want to define a threshold, yeah? And you can do it for every single test here. So it's result validator, exactly, and then threshold validator, and here you define, yeah, like this, F. And it means if the difference between both screenshots is less than 0.15% of the pixels, then it will pass. For shot, actually, you can configure it only at the Gradle plugin level. So it will be for all the screenshot tests, what is not good, not as good as this. So for, actually, I will show you briefly, yeah. So recycle view, shot. Or yeah, actually here you can define like tolerance equals 0.15. And it means 0.15% of the pixels, which is not too much. Yeah, but yeah, as I said, this would be for all the screenshot tests. So those are the differences. And now I'm coming back to, one more thing. What does it look like when the verification fails? For shot. Yeah, so we go again to the shot screenshot test. That was in lazy column, shot, Java workshop, screenshot test. Here again, latte. But here we have to execute the screenshot test, the verification from the command line. There is no other solution. So we execute it. And let's see what it looks like in the report. And after that, we are done with the on-device screenshot testing. Yeah. Very good. The build failed, of course, something that we expected. Report here. This is the Gradle configuration. Sorry. Yeah. So we go here again. Let's take a look at the report. Yeah, you see this. And then here the div, which does not display too much. The new screenshot that is with latte, and then the difference between both. This is because I was taking a screenshot with bitmap, one of them, and the other one was not with bitmap. That's why everything is red. But yeah, this is more or less what it looks like, yeah, just for you to get an idea. Good, so we are done with on-device screenshot testing. Let me continue. Well, we are actually not completely done. So, no, you are not seeing what I expected. Yes, no, yeah. So here I have a comparison table for both screenshot testing libraries. Yeah. Honestly, I haven't talked about the configuration, but with shot is a little bit, yeah, problematic because it does not support AGP8. There were problems in the past with Windows. So if you have a Windows machine, maybe the test won't work for certain API levels. And also that if you are using Kotlin build Gradle files, it might not work. With Dropshots, it's very easy. Yeah, also one thing that I haven't mentioned is that none of them supports Gradle managed devices. If you actually want to support Gradle managed devices, you should build your own solution probably, because I think none of the libraries supports that. And yeah, the only thing that I find very positive regarding shot, yeah, is that you get very nice HTML reports comparison to Dropshots that generate some files. Yeah, sometimes it does not generate it, like today it did not generate it. But yeah, all in all, I actually prefer Dropshots, if you ask me for my opinion. There's also one thing that I want to talk about, and it's the Android orchestrator. So I often hear that the screenshot tests on device are very slow. The truth is, they are not as fast as JVM tests, but they are not slow. And the main reason why they are slow is the Android orchestrator. And I want to show you a video in which we run 18 tests with and without Android orchestrator. And we are going to see the differences. Yeah, so what's the difference actually is without orchestrator, when we are running our screenshot test, it will open a process and then it will execute test. With Android orchestrator, it's not like this. It will start the screenshot test, so it will open a process, execute one test, close the process. Open a process, execute the screenshot test, close the process. So this opening and closing is taking a lot of time. And that's the reason why screenshot tests are very slow. with Android Orchestrator. So you may think, yeah, okay, but Google recommends to use Android Orchestrator. Well, so what's the problem that actually Android Orchestrator is trying to fix? So it's trying to fix the problem that we have dependencies between tests. Yeah. So for example, you start a test. It executes an operation asynchronously. The first test finishes. And then we start the second test. This ongoing operation finishes, and it affects the result of the second test. Right? That's basically what it's trying to avoid Android Orchestrator by running every test in a different process. So when do we need actually this? When something asynchronous is happening in our screenshot test. That would be for activities, fragments, or something when we are fetching data, for example, in onResume and those things. But if we are just inflating one view and populating it with data where nothing asynchronously is happening, we don't actually need Android Orchestrator. And our test will be much faster. So as you can see, yeah, the difference is pretty big, and it's only for 18 tests. So the more tests you have, the more the gap is going to be bigger and bigger. So just for you to know. So now it's coding time, but it's for the JVM test, yeah, Roborazzi and Paparazzi. That I guess is going to be the main dish. There are a lot of differences, by the way. So yeah, let me finish. Not finish. I'll change this. Wait, open Android Studio. Yeah, you're not seeing that, but you will see it now. Yeah. Good. So I'm gonna close this. I'm gonna do the same, but I'm gonna start with Roborazzi. So I'm gonna write activity screenshot test with Roborazzi. Yeah. So again, Roborazzi screenshot test. A lot of concepts are going to be repeated, yeah? I'm going to show you with the language training activity, yeah, like this. So there are some things that are important in Roborazzi test. It uses actually Roboelectric under the hood. So for that, we use the Roboelectric test runner, which sets the environment for Roboelectric to run. So it downloads resources. It sets also some mocks and so on. And also this graphics mode annotation is to enable Roboelectric native graphics. That is actually required to take a screenshot test. And also something I want to mention is that by default, Roboelectric takes a small device with a very low resolution. So you can actually modify that, but using a qualifier. Qualifier you can define is actually a string where you can define, with different qualifiers, where you can define the screen size, like a screen height, a screen width, density. You can also define night mode or not, the locales and so on. And this is from Roboelectric. But Roborazzi, that is the library we're using, provides some default qualifiers for that. That is this one, Roboelectric device qualifiers from Roborazzi, as you can see, and we are going to use Pixel XL. Because otherwise it will look very weird, the screenshots, and you are, what's happening? Well, and now we do like before. So wait for activity, and then we say, Roborazzi for taking screenshots. Actually, what it does, it provides some extension methods from views and bitmaps as well. So you basically need to take the view from the activity that is like this. So activity window, the core view, and then we use this method from Roborazzi that is called capture robo image. And it actually takes a file path, so the full path, where you want to save the screenshot. So you can define where you want to save it. I created a method. This actually is saving the screenshot in this, directory, where I'm writing the test itself. So I just give the name here, that is going to be, guess what, activity. and I just have to execute from the command line. That is here up, record. And let's see what we get. Yeah, when you have several screenshot tests with paparazzi the same, with Roboelectric or paparazzi, at the beginning, the first test, the very first test, you are downloading resources, so it takes a little bit longer, but the rest of the tests are faster. So it was generated, but I have to change to project, sorry. Again, recycle view, Roboelectric. Yeah, here, activity. And this is what it looks like. And again, it does not have shadows, right? Well, you may think, yeah, actually, Roboelectric support bitmaps. You can do the same as you did before. Unfortunately, with Roboelectric, it does not work. There is an issue. It's open. Shadows are not visible with Roboelectric native graphics. It has to do with Roboelectric, not with Roboelectric itself. This is, I would say, the main issue with Roboelectric native graphics. Yeah, it's still not able to render shadows. I know Google is working on it, but yeah, it's the main thing in comparison to paparazzi, actually, as we'll see later. Good. That's for activity. Now we are going to do the same, but for viewholder, where we can actually do pretty much the same as before. Again, you can have the same problem. Yeah, if you are just fetching some data and so on, you have to implement some waiting mechanism. Yeah, also the Android UI testing utils provides one class for that is called Roboelectric activity scenario for view rule. Also for composable, there is one, just with the prefix Roboelectric, so very, very similar. And then we do basically the same, yeah, so as we were doing before, so it's, same was this, yeah, exactly. So you can inflate in this empty activity, oops, yeah, your layout, then you say, training, you hold, yeah, the same as before, but now we are gonna test the empty state. So this holiday empty state, yeah, so to speak. And now, yes, very similar to before, viewholder, item view. And as I mentioned, there is this extension method for views and bitmaps. Yeah, capture raw image. Then we have the file path. And this one, I will call it training viewholder. Yeah, like this. You can also use this, wait for master viewholder, and so on. So everything exactly the same from Android UI testing utils. And I execute it. Yep. I'm actually also filtering the test, yeah, by the way, by name. Those that finish with the screenshot test. Gradle also allows you to filter tests like this. So it was already generated. If it does not show up, you can reload from disk and it appears here. Yeah, so it's done. Good. This one didn't have shadow, so everything is fine. Yeah, and now let's do the same for composables. This is gonna be interesting, I can tell you. Let's see the limitations of Roboelectric with composables, or the no limitations of Roboelectric, because everything is related to Roboelectric, not to Roboelectric exactly. So lazy column, I'm gonna close this. Roboelectric, yeah, here. Again, so Roboelectric, yeah. Yeah, exactly the same as before, the test runner, graphics modes, configuration. And then we have the capture robo image. Yeah, for composable, there is no extension method. There is this capture robo image method where we pass the file path again. File path, exactly, file path. And this, I'm gonna call it coffee again. And here we just write the same as we did for on-device screenshot test. What is gonna be coffee drinks, this item, the coffee drink, you, and then that's it. Actually, capture robo image uses compose test rule under the hood. And that's it. As simple as this. We can just execute our screenshot test. Copy and paste. So here, coffee. Yeah, it doesn't show background, but it's because the background is set in the activity actually. But when you draw a bitmap, it also shows the background. So good, it's actually what we wanted. Okay, so also from Roboelectric, you can run a screenshot test under different API levels. There's an annotation from Roboelectric, not Roborazzi, that is config actually, and instead of qualifiers, apart from qualifiers, we can set SDK levels, and this is an array, so let's do it for 30 and 31. Yeah, and instead of using this, we're gonna use coffee drink app bar, because it accepts one argument that is a string. And what we are gonna show here is the API level. This is the top bar where it's written coffee drinks at plus this string that is gonna be the API level. So coffee drinks at 30, why not, or 31. So for that we have to pass the SDK, yeah? So from Android code, we can get it like this. Yeah, so we just pass this. And then what it will happen is, I'm gonna call this coffee bar. It's gonna execute two tests. The first one, API level 30. Here it's gonna return 30, and then here it's gonna generate a screenshot file called coffee bar. Then 31st, it's gonna be here 31st, and it's gonna create again coffee bar. So it's gonna override the already existing file. So how can we solve this? Well, we just add here this variable that we have created, and that's it. So it will generate two screenshot tests that have as suffix the SDK level. So now we execute it again, and this is gonna take a little bit longer because the Roboelectric test runner has to download the resources for the different API levels, right? For 30 and then for 31. So one completed. Two completed. Let's see. Yeah, 30, coffee drinks at 30. Good age, by the way. And coffee drinks at 31, so it works. Very good. And now what I'm gonna show you as well is, can we screenshot test a snack bar? So for that, let me do this scaffold. Okay, I'm gonna delete this. And also this, no more SDK. And we are gonna call this a snack bar. Yeah, so scaffold, and then there's this snack bar. When you click on one of these coffee items, that says support, action not supported. Yeah, it's this one. This is snack bar scaffold, no magic here. Yeah, it's just a scaffold with a snack bar host state. I didn't want to repeat this code several times, so I created this. Because to show a snack bar, you need a snack bar host state. And well, that's it, basically. So let's see if it's able to screenshot test it. The most important, why I want to screenshot test on a snack bar is because this is using a launch effect, to show the snack bar. So basically, I want to know if you can, with Roboelectric, screenshot test a snack bar, something that happens in a launch effect. So it's already generated. Here, load from disk. Let's see. Yes, it can. So it's possible to screenshot test something that is in a launch effect with Roboelectric. Good. So yeah, that's it for Roboelectric. Let's do the same for Paparazzi. Well, let's write a screenshot test for an activity with Paparazzi. Unfortunately, it's not possible because activity scenario, yeah, supports Roboelectric, but you cannot have the same test, in the same test, Roboelectric and Paparazzi, yeah, because the Roboelectric test runner says, hey, let's download the resources, yeah, set the mocks and so on. And then comes the Paparazzi rule and also wants to do the same and also set the same mocks. And then the GVM says, sorry, but what you are trying to do is not allowed. So yeah, this is something that does not work because of the way Roboelectric and Paparazzi do things, yeah, download the resources and so on. So yeah, if you want to screenshot test activities or fragments, you cannot do it with Roboelectric or Paparazzi, sorry. But well, for the view holder, we can do it. So let's see. I'm gonna close also everything that they have here. Yeah, actually I said that, yeah, maybe I could take some questions. Let me finish this part and then you can ask some questions before I continue. Yeah, so recycle view screen, Paparazzi, workshop. So here, Paparazzi, screenshot test view. So Paparazzi needs actually this test rule for taking screenshots. Uses, yeah, by default Nexus 5, so you can configure it here. And since, yeah, I also have my own theme, I have to define it here, otherwise it won't take any screenshot. So we have this snap view holder. So Paparazzi to take us, oh, yeah, sorry. There's Paparazzi, there's this inflate. Yeah, so wait, I'll do it like this. Paparazzi, yeah, this one, the Paparazzi inflate view. Again, this training view holder. And then we just have to do Paparazzi. Yeah, we want this as view. Oh, I have to, yeah, the view holder, sorry. I have to, here we have inflate the view, but we have to populate the view holder with data. So it's gonna be like this. And we want to screenshot, oh, yeah, this, I don't need the master view holder. NT training item. Very good. Here we say view holder, item view, and then here name. It's gonna be training view holder. And that's basically it. Yeah, for the NT training item. And let's see what we get. Yeah, again, it's downloaded also resources from LayoutLib, so it takes a while. And then it's generated. Here we also get a report. And here, well, there are several things that are wrong here. Let's go one by one. First of all, we are showing the system UI and the navigation bar. We can remove it. Secondly, we are screenshot testing the full screen. And there is also something wrong with the view holder. This is not what we expected. What we expected is this pond, beach, and sand, yeah? Well, let's fix this with the system UI and the bar. So for that, with Paparazzi, you can use this, yeah, show system UI false, so the system bar is not displayed. And then inside device config, you can say, yeah, don't show the sub buttons. And then instead of having a screenshot of the full screen, we want to have a screenshot that just wraps the view. So for that, we are going to have here, yeah, so Roboelectric actually has rendering mode, which has, yeah, several things. There is rendering mode V-scroll, so for vertical scroll, when the view goes beyond the limits of the screen, so to speak, to full screenshot test it. Then we have the same for horizontal scroll. Then we have Normal, that is the one that we have seen. Full expand, that is vertical and horizontal together. And then we have shrink, that is just to wrap it. So what we need is shrink. So if I take a screenshot of it, now it should be actually fine regarding the dimensions. So we execute it. Yeah, was executed. Well, there is actually a difference. Yeah, here was showing words to train, this up. Here is not. That's actually something that happens with some views when you use shrink. There is a way to fix this with paparazzi, that is here screen height. You can set it to 1 and here vertical scroll. And then it will be fixed, as we will see now. Yo, executed. Boom, it shows, but it's not showing still the what I said, what we expected. Yeah, that's because, yeah, that's a problem with paparazzi actually. Yeah, the animation that is happening, I mean, there are several animations happening, one after another. We are making some views gone, other views are becoming visible and so on, and somehow paparazzi is not able to handle this when animations happen one after another. There are some mechanisms that paparazzi has for it. There is this instant animation rule to execute all the animations just now. And there is also here the offset of milliseconds. You can set it to whatever you want. I would say 8 seconds. This is not going to help. It's still not going to display it. It's just a mistake somewhere, a bug in the code in paparazzi. So yeah, one more point for Roboelectric. If you have some complex animations, yeah, so again, nothing changes. You have some complex animations, yeah, go for Roboelectric. At least for views, yeah, for composables, maybe it's not the case. So, yeah, then we are done with views. Let's go with composables, with paparazzi. And once I'm done with this, to do workshop screenshot test. So again, paparazzi screenshot test for composable. Yeah, here I'm using shrink. For composables, I haven't found any issue. And here, yeah, with paparazzi, it's pretty simple, with all libraries, actually. Here, lambda, very similar to Roborazzi, or Roborazzi, very similar to paparazzi. And here, name, it's gonna be coffee. And then we execute here. Yeah, item, it's gonna be coffee drink. And yeah, let's execute and see what happens. Yeah, well, I can tell you it's gonna be fine, as expected, yeah. So, well, it's a little bit small, but yeah, it's what we wanted, so to speak. So now, let's see screenshot testing for different API levels, yeah? Well, yeah, that's actually one issue in paparazzi. This has nothing to do with layout lib. It's just paparazzi that cannot do it. Yeah, support different API levels. They just take the one from layout lib. And they don't try to, I mean, there's a bug. They will probably fix it at some point. It's, yeah, reported in 2019 by the author, actually. Yeah, so that's something that Roboelectric can and paparazzi cannot. Then let's see what happens if I try to screenshot test and snack bar, or something inside the launch effect, yeah? So action not supported. The same as I did. Here it's gonna be a snack bar. Yeah, and I execute it. Yeah. So, yeah, nothing. Unfortunately, this is because lib. So something that runs in a launch composable, launch composable, launch effect in compose. Yeah, is not display, cannot be done. But with Roboelectric you can. So those are the main things that I wanted to show you. And again, I have a table here where I summarize everything. Let me come back to this. Wait. Yeah. So here are the things that I'm considering. I didn't talk about configuration. One more point for Roborazzi, because it supports Basel, and it also supports app and library modules. So you can write the screenshot tests inside application and library modules. With Paparazzi, there's no Basel support, and you can only write a screenshot test inside library modules, not in application modules. Then, for me, there is also a clear winner, and everything, that is supported there is because of Roboelectric. So you can actually create your own solution based on Roboelectric, and everything will be fine except this render elevation, shadows and so on. Yeah, it's a pity. But still, it will probably also be fixed. So, well, but we have a screenshot test. Actually, before I start with the next section, if somebody has some questions, I can take them, because I need a little bit of water. If not, I will continue with the last part. Yeah, please, or you can come to the, I don't know if there is a macro, yeah.
Hi. How easy is it to integrate all of these or each of these into your CI pipeline? Do you need anything special? Probably everything that you also need for instrumented tests, right? Or
I couldn't, acoustically, I could not.
sorry, do you need to integrate each of these into your CI or CD pipeline? Anything special?
If there's a special?
Or like any dependencies and frameworks you also need for instrumented tests?
No, actually, what I've done to do you talk about any library in particular or just in general?
Not any of these, yeah.
Actually, I've always done it with command line, for integrated in the CI. My favorite solution is actually to run a screenshot test for JVM locally and on the CI on device, because of some things that I will explain later. This has to do with fidelity. You are running actually the screenshot test on a real device that is where it's gonna run, because Roboelectric is actually still like an amount of fakes and mocks. Paparazzi is just layout lib that is for previews. It's actually not even for screenshot testing. But it's pretty easy. Actually, I think Roborazzi has even, there's another repo that from this author, from Roborazzi, that makes it even easier to integrate it in continuous integration server.
Okay.
It's a Google developer expert, Takahiro from Japan. You can check, when you check Roborazzi, just check what he has done in the repos, and you will find something that makes it very easy to integrate, because the main problem, I think, in the CI is that in the end, you will end up with a lot of screenshots, and somehow you want to delete some of them. And this from Roborazzi, from the author, actually deletes the screenshots when the branch is gone, something like that, I haven't tried, but it's very simple to integrate it in CI,
Thanks.
Good. I can take one more question, At the end, you can also ask something if you want,
Thanks for the presentation. And which platform, which library are you using now for your projects, actually?
In my current project, we are not using any screenshot library because I started like 1 month ago, but we are going to integrate it right now. And if I have to go for one of them, I would go for Dropsos and Roborazzi, depending on what you want. Yeah, yeah.
Okay, thank you.
Good. So I'll continue. There is one more part. Let's see how much we can do out of it. Oh no, I still want to continue with this. It's 35. So you can see, yeah. So yeah, we have written a screenshot test only for default configurations, but there are several configurations. Yeah, yeah. Our users use the app under many configurations like locales, portrait, dark light mode, and all that stuff. And yeah, for me, those are the most important configurations probably, and I want to go through 3 of them. That I consider important or not so well known. One of them is the locale. Yeah, so the more languages that your app supports, the more screenshots you are going to generate. Yeah, if you want to screenshot test for all the locales, and at some point it will get out of control. Yeah, the more languages you support, the more screenshots. So you can always use pseudo locales. There are 2 supported by Android. The English XA. Well, basically it takes the default strings, adds some words at the end, and it also replaces some characters with other characters that have some glyphs, like accents, tildes, and so on. And then there is the Arabic XB, that what it does is also takes actually the string source resources, the default ones, and it mirrors them, and it also mirrors the layout. This is actually pretty interesting if you are planning to support right to left languages in the future and your string resources are not ready. Then we also have font size that is for accessibility issues, to find accessibility issues. Actually, yeah, you can go under settings, display font size. And if you have never tested your application under different font sizes, I recommend that you do it because you will probably find some issues. I always find some. And there are many users that use this huge font size. Then there is also something that is not very well known, that is the display size. Also, this is not a developer option. This is a real option that our users can select. Under settings, display size. And it would actually look like this. So what it makes is it makes the full layout bigger. So it's for people that have fat fingers, yeah, to tap easily. And also important, yeah, you can have actually, I mean, there is a difference between font size and display size, as you can see. So more or less the font size is the same, but the image is bigger, yeah, because of what I said. And you can have both enabled. I don't believe many users enable both, but you could have both enabled, and it would mean the font scale will scale even more. So, well, how to screenshot test so many configurations? Depends on the library, actually. For paparazzi, yeah, almost everything out of the box. Some things like display size and orientation are also possible with a little bit of trickery. Yeah, Roborazzi almost the same, except for custom themes. And for on-device screenshot testing libraries, you can use Accompanies from Google or Android UI testing utils. Accompanies from Google only supports composables. Android UI testing utils supports both. Yeah. So it's coding time. The last session is going to be very, very fast. I'm going to show you how to do it with different libraries. Shot and drop shots is exactly the same. It's with these Android UI testing utils. So now I'm changing. I think it's right. Yeah, you see it. Good. So I'm going to do it for the view holder. So recycle view screen. For drop shots, I said. So workshop, screenshot test. Here we are. So how can we integrate it? So here we are already using Android UI testing utils. There is this thing that allows you to do it for, set all those things. And if we change it, for example, UI mode night, and as you can see, we are using the pseudo locale. Done. Let's see what we see. Let's see what we see. Repeat myself. Yeah. Yeah, the same for wherever you use this Android UI testing utils is the same for all of them. There is the same for composables. Yeah, this is view config item. For composable, there is composable config item. Yeah. So, and we see what we got. That's, no, this is crash. Wait. Not exactly what I was expecting. It's a drop shot, yeah. The screenshot is here. Yeah. Yeah, this is what I meant with the glyphs that are changed with XA, English XA. It adds some words like 1, 2, 3, and so on. So the layout is actually broken, yeah. That's interesting because you can text with this pseudo-locale English XA. Yeah, what happens when the strings are longer than expected for languages like German, actually, or Japanese. Good, so as simple as it is. Yeah, this is the night mode of a custom theme, by the way. You can always run the screenshot test here in the repo and try it on your own. Well, let's do the same for Roborazzi. But for that, you can do it via Roboelectric. Actually, it supports also via qualifiers, as we're gonna see now. So Roborazzi, I'm gonna close this, and this. So Java, workshop, screenshot test. And yeah, so what you can do with Roboelectric without Android UI testing utils, this is pure Roboelectric. You define your default configuration. So you take this here. And then with Roboelectric, you can extend the default configuration. Because in these qualifiers, you can also define, as I said before, things like night mode, locale, and so on. So for that, you just have to add this plus. That is like, hey, extend the default configuration that we have defined here up, that applies to all the tests here inside this test class. And then we say night. And then if we execute it, but not with empty, let's execute it with something inside, as before. Yeah, then it will be in night mode, which is also blue, but a little bit darker. Well, it's gonna take. Then we could also do here, I don't know, other language. So we could do Arabic. Wait, now the training view holder. Yeah, it's also, you see the background that is dark, and this is this blue is a little bit darker than it was before. Then we say, okay, let's do it Arabic, yeah? And now the thing is, it's gonna fail. Yeah, but it fails because the problem with the qualifiers is that they have a defined order. So the locale should not be at the end, it should be at the beginning. If you do it like this, it will actually work. That's one of the problems with the qualifiers that I don't like from Roboelectric, is that you need to know the order. There is also, we'll see now, yeah, no, it should be in Arabic. Yeah, exactly. Yeah. I don't know if it's right what is written, honestly. But yeah, well, and then, yeah, that's what I wanted to show you. There's one thing that you cannot configure via qualifiers, that is the font size. For that, there is extra one, and I could write like this, and then it would do it. Yeah, but for the rest, you can do it here, except custom themes that you cannot define with qualifiers or with font scale. And that's where actually this comes in. We can remove this configuration here and also here, and use here inside our Android UI testing utils class. There is we can define the devices screen. That is gonna be the pixel XL as before. And here we do as before. We can support all of them like this, easy peasy. So I'm gonna do here night, It's also the custom thing. Yeah, if I execute it, yeah, it will run. Yeah, with the expected configurations. Yeah. Good. Also display size that you cannot define it via qualifiers is also possible. A little bit tricky, but yeah, I think it's not so important. Good. And then I click here again. Yeah. So this is what I get exactly. Yeah, with the NXA night mode thing custom. Yeah, and then yeah, let's go with paparazzi, the last one. And then we're good to go. No, this is Roborazzi, sorry. Paparazzi, Java, workshop, screenshot. We are gonna do also something. Wars, no. Yeah. Training view holder. And then here is paparazzi. Yeah, so what is important here, this is how you define it. So night mode, font scale, locale, orientation, and so on. There are some things, yeah, here theme, and you have also for Arabic, for example, or right to left languages, you also have to set this to true. Yeah, so if I will change this. If I execute this, yeah, it's not gonna work because there's one more thing that paparazzi does not support. It should fail. Maybe now it's supported. It's the same version as when I try it out. Yeah, build fail, and that's this thing here. Paparazzi does not support pseudo-locales, and that's because of layout lib. It's not supported in layout lib, so why should it do it paparazzi? Yeah, but if I do like, let's say Arabic, exactly the same, yeah. It should build and work. This is not very important, honestly, that you don't support pseudo-locales. It's just a nicety. Yeah, exactly. So here you have it. Oops, yeah, this is the history. Yeah, good. Yeah, almost done. Also, orientation does not work like this exactly. It's a little bit tricky. You have to change the height with the width, and then it will be like real for real landscape, because what this describes is that this is the default orientation, not the real orientation of the device. Yeah, so yeah, I think that's it. I mean, still I have some, like 5 slides. I'll go in 3 minutes through them, and we are done. Yeah, so on device or JVM, well, actually, I just removed configuration because it really depends on the library. But if we add also the on-device screenshot test libraries, well, everything is supported, also the render elevation. Yeah, but this is a little bit unfair, yeah, being honest. So, yeah, my personal opinion, when to use on-device and when to use JVM. Use on-device when you want to get the best fidelity, because you are running actually the screenshot test on a real device or on an emulator, which is close enough. Yeah, and otherwise you are running either screenshot tests based on layout lib, which is actually not what they are running. Otherwise, you are also running the screenshot test on Roboelectric, which is also like pure mocks, not pure, mainly fakes, not mocks. But it's also not the real system, and sometimes it could be that something does not work. Then also, if you want some special configuration, you can always use ADB, which is actually pretty cool. There are some things that you can do with ADB, like setting dynamic colors, which is not documented, but it's also something that you can do. Yeah, also like some accessibility options like high contrast test, yeah, safe battery mode, or something like this. Then also foldable support. For foldables, I would strongly recommend it because, well, Roborazzi and Paparazzi have some device configurations for foldables, but they are tablet-like, honestly. So yeah, supporting tablets is, supporting foldables is not supporting tablets, because foldables you can fold in, fold out, they're flippable. Maybe you have a hinge in the middle and dual display, and that's kind of impossible or very hard to configure with Paparazzi or Roboelectric. But on the other hand, JVM is also pretty useful because they are very fast. So for example, for local development, I find it amazing. The feedback is more than enough what you get, even if it's not the same as in a real device. They are less flaky, mainly because you won't have issues with emulators, freezing on the CI, for example. And also, very cool, accessibility services. I didn't go into this. In this repo, you can check it. Roborazzi and Paparazzi, that does not have to do with Layout Lib or with Roboelectric. It's specifically Roborazzi and Paparazzi allow you to screenshot test accessibility tags and a lot of information that is pretty useful. And honestly, it's more pragmatic than doing it on the device. So really, really recommend that you take a look at it, both supported. And well, last but not least, yeah, this is actually from a blog post that I read some time ago from Ubiratan Suarez. He talked to Ryan Harter, I think, is the author of Dropshots, one of the libraries that I was mentioning. They were discussing that actually the best is probably to have a dual approach in which you combine JVM and on-device screenshot testing. I completely agree with them. You can get solid visual feedback with on-device screenshot tests, and with JVM you just have fast feedback, yeah, for example, for local development. So, just last slide, this I promise, just a recap. The GitHub repo is there. I strongly recommend it that you take a look because there are many, many more things that I could not cover. And also the Android UI testing library there. One of the niceties it has, is still in beta, is that you can write a screenshot tests that are cross-library. So you write the screenshot test once and you can run it with any of the libraries. Now it's only supported for composable, this feature, but it's coming for views support also soon. And that's it. Thank you for your attention. I will share the slides in LinkedIn and in Twitter. If you want to read more about the screenshot testing, my blog post, I have a lot of blog posts about the screenshot testing, and my GitHub repo where you can find everything. So thank you very much. Good. Thank you.